Students, my name is Munish and welcome to Bonsai Education Initiatives, and today I'm going to start chapter probability, which would be relevant with Cambridge IGCSE O-Level mathematics. Let us see. Probability. Probability basically is a game of chance developed by Mr. Blaise Pascal. The game of chance is the study of chance, which means we can predict something with the past experiences or with some certain conditions. We can predict the future. And when we are predicting the future, we cannot be sure all the time, but sometimes we are having certain, sometimes we are having that it is not going to possible. For an example, sun rises in the east. What is the probability for tomorrow? From the past experience of hundreds of years, we are very much sure that sun is going to rise in the east, but sun is going to set in the east. From the last past experiences, we can predict the future. Certainly that sun is not going to set in the east. So that is an impossible thing. In that way, we can predict. For an example, in a certain day, the chance of the rain is 60%, but chance of not rain is 40% because total is 100% is considered generally. So this 60% can be converted into fraction. When we have percentage, we remove the percentage sign and we put 100 in the denominator. And when we simplify it, we got a fraction. So this fraction is considered as probability. So 3 by 5 or 60%, both are the same thing. So we can say there is a probability of 3 by 5 of having rain today. So 3 by 5 means it's a fraction, and out of 5 chances, there is highly likely 3 chances which tells us that it is rain today. It is going to rain today. And not rain, for example, 40%, if you convert that into the fraction, and you are going to have 2 by 5. 2 by 5 means there is a less probability, less chance as compared to the rain. So 2 out of 5 say no, not rain, and 3 out of 5 says it will rain today. So that is how we predict the chance in the terms of probability. Now if you see carefully, I draw this number line. This is 0 and this is 1. So what does it mean in the terms of probability? Because we cannot have negative probability. So 0 means sun is going to set in the east. What is the probability? Sun is going to set in the east. That is 100% 0. We say that it is an impossible thing. It is not going to happen. So when we have impossible thing, it means the probability in the game of chance, we say probability is 0%. Probability is 0%. 0% means probability is 0. Because we are having 0%, it gives us 0 by 100, and which is equal to 0. For an example, take when a die is rolled, what is the probability of getting 7? So die has 1, 2, 3, 4, 5, 6. It cannot have 7. So probability of getting 7 when we are rolling a die is 0. 0%. So 0% mean it is an impossible thing. Hence the probability is 0. But on the other hand, I have marked 1. What does it mean? That when you are rolling a dice, what is the probability that the number will occur from 1 to 6? Of course, 100%. Out of these 6 numbers we would be having like out of these numbers 1, 2, 3, 4, 5, 6 will be having the numbers from these only. Hence, for this condition, the probability is, the chance is 100%, and 100% means it is certain event. It is certain event. So you need to be very careful when we talk about impossible event and when we talk about certain event. So it means the probability of any event, it lies between 0 and 1. Probability lies between 0 and 1, and 0 and 1 are included. Probability can be 0 itself and probability can be 1. 1 means 100%, 0 means 0%. It means probability always lies between 0 and 1. And if you see carefully, if we are close to 0, let us say 30%, then we are close to 0. If the probability is 70, chance is 75%, then we are close to 1. And moreover, probability of any event, this is the equation or inequation you need to remember. So probability always lies between 0 and 1, where 0 and 1 are included. So how probability is calculated? We have a general formula that probability of an event is number of favorable outcomes upon total number of possible outcomes. Favorable means what we are looking for. Total means that what are the total possible outcomes. For an example, if we see if we roll a dice, what maximum numbers we can have? We can have 1, 3, 4, 5, 6. So this is called the sample space. We are going to discuss in the forward lecture. So this is the total number of outcomes. We hadn't chosen what we are looking for. This is the total output. So it means the n is 6. That means total number of outcomes are 6. Now you are looking for even numbers, let us assume. Then your favorable outcomes, for what you are looking for the answer, you are looking for odd numbers. We copied the odd numbers from here, then 2, 4, 6. It means n is equal to 3. So favorable outcomes are 3 and total possible outcomes are 6. It means probability of getting even number is number of favorable, which were 3 here, and total number of possible, which are 6, and it is going to be 1 by 2. In that way, we will be solving a lot of problems in the future, okay? So sample space means in probability the list of all possible outcomes. Whatever you are looking for, that is a separate issue. What the event, what the experiment can offer you. So sample space, the list of all possible outcomes. All possible outcomes when an experiment is made. Okay, let us see some examples what I'm talking about. Okay, when you toss a coin, what possibilities you can have? What possibility you can have? You can have either tail or head. If you toss a coin, the coin can land on heads, or you can see the tails. So in that sense, the sample space for tossing a coin is given by this sample space. So this would be the list of all possible outcomes is called sample space. On the other hand, if you are looking at the dice, for example, in the dice, what you are having here, when you roll a dice, what are the possible outcomes which we can have? So the possible outcomes we can have are 1, 2, 3, 4, 5, 6. There are 6 possible outcomes. Hence the sample space when the die is sample space. When the die is thrown, rolled, this is the maximum possible outcomes we can have. So hence we are having 6 possible outcomes, and hence the sample space has 6 values. And when we are calculating the probability of getting an heads, so getting a heads, go here, see the total outcomes are 2, so maximum possible will come here, the sample space count come here, total number of possible outcomes. And what you are looking for the tails, hence there is 1 tail, hence we took 1 here. So probability is 1 by 2, simultaneously probability of tails we can have 1 by 2. Moreover, when a dice is thrown, there are different kind of questions which can be framed here. Probability of an odd number. So what are the odd numbers here? Odd numbers are 1, 3 and 5. That is going to be your favorable. That is going to be your favorable. And total we are fixed. Total we cannot change. There are 6 possible outcomes. So out of 6 we are looking for 3, because favorable is 3 here. So the fraction is 1 by 2. Hence there is 50% chance of getting an odd number when we are rolling a dice. On the other hand, probability of composite number. So composite number, we have to choose a composite number from the sample space itself. Okay, so if we see the numbers, composite numbers are numbers. Composite numbers are numbers which have more than 2 factors, or you can say the number other than prime. Those are called composite number. So what composite number we are having here? We are having 1 is neither prime nor composite, 2 is prime, 3 is prime. We are left with 4 and 6. So composite numbers are 4 and 6. So hence there are 2 count of favorable outcomes. So hence probability is 2 by total outcomes 6, 1 by 3. Probability of factor of 8. When we are rolling a die, probability of factor of 8. If we factorize 8, what we are going to have? 1, 8, 2 and 4. So factors we have 1, 2, 4 and 8. What is the probability of factors of 8? So out of these, which numbers we can see here? Okay, so 1, 2, 3. 3 numbers can be occurring here out of 6. So out of these numbers we can have 3, the probability is 1 by 2. So in that way the formula works. Okay, let us move further. If we are tossing 2 coins together or 1 coin twice, the question can be asked in any way. If we are tossing 2 coins, both the coins can land on, both can be having heads, both can be having tails, one tail, one head, or on the other hand, this can have head, this can have tail. So there are 4 possible outcomes which are listed as head head, tail tail, head tail and tail heads. That is the sample space for 2 coins. That is the sample space for 2 coins. Okay, so the questions are asked like the probability of exactly 2 heads. So we have to look at these outcomes and find how many terms which are having exactly 2 heads. So we are having only 1 term here. So hence the probability is 1 by 4. Probability of 1 head. 1 head means we have to look for the outcomes which have only 1 head. So here 2 heads, no head, 1 and 2. 2 outcomes here are showing us that the outcomes are having 1 head. So hence the probability is 1 by 2 after calculating. I hope you are understanding. And probability of at least 1 head. At least means, that is the very common phenomenon and question is asked. At least means minimum 1. At least 1 means minimum 1 and maximum can be anything. So you should be having at least 1 heads. 2 heads are there, fair enough, you will take that. 3 heads are there, you will take that, whatever it is. So at most mean minimum 1 and you can write that maximum is infinite. Kuch bhi ho sakta hai, maximum, we are not bothered for the maximum 1. Okay, so at least 1 head. So we need to take 1 head means we have to exclude which are having less than 1 heads. It means what you are going to do here, okay, this possible outcome, TT doesn't have at least 1 because it doesn't have any. So what we are looking for at least 1 is, it means we'll take this one, we'll take this one and we'll take this one. So hence 3 outcomes are there which are having at least 1 head, then 3 by 4. And sometimes you are asked about the term at most. At most means 2 heads. It means maximum 2 heads can be taken, not more than 2. If some outcome has 3 heads, then that will not be considered here. Maximum is 2 and maximum 2 means if we cannot have 3 heads, but less than 2, all the outcomes will be considered, even 0 will be considered. It means if you see carefully here, this thing, okay. If you see carefully, we are looking for at most 2 heads. At most means 2 head or less than that and 0 included. This means what we are having here, 2 heads means that would be considered, 1 head that would be considered, 1 head that would be considered, because we need maximum 2, and tail will also be considered because we are concerned about the maximum 2, and if the minimum is 0, that will be taken care. So hence we are having here at most 2 heads, we are having 4 by 4, the probability is 1. Next, let us move further. If we are having 3 coins, so 3 coins means we are having 3 different coins and we are tossing them together, and whatever is appearing on the top of the coins, we are noting them down. So what we are having here, 3 coins, and this is 3 heads, 2 heads and tails, HTT, TTT, TTH and so on. These are the 8 outcomes. Sometimes the students get confused how to write these 8 outcomes because they do not follow a certain pattern. For an example, then I made a small trick here. If you see it carefully, this is going to help you in the exams. Okay. Okay. What you do? You copy down the outcomes of 2 coins. 2 coins is easy. You can copy down the outcomes of 2 coins, and you need to write down the duplicate of this here. Okay? Copy down the outcomes for the 2 coins which we had here, like HH, TT, HT and TH. That is quite easy. Okay? And here copy down it and write and duplicate. Do the same thing. And for the first thing, you can put here all T's, and here you can put all H, or vice versa. Either you can write H here or T there. So these are the 8 outcomes when 3 coins have been tossed. That is a fantastic method, and you do not need to learn anything, and the answer would be correct. And different kind of questions can be asked. 2 heads, we have to find the outcomes which are having 2 heads. So 2 heads here, 2 heads here, and 2 heads here. So we are having 3 outcomes out of 8 which are having 2 heads. So hence in that way the probability is 3 by 8. And probability is 1 tail and 2 heads. 1 tail, 2 heads. We need to look at the terms which are having 1 tail. So 1 tail and 2 head, that is this thing. 1 tail and 2 heads, and 1 tail and 2 heads, 3, and that's all. So we are having the probability is 3 by 8. In that sense we deal with the coins. Now toss a coin and roll a dice. That is a question which had been asked many times in the past papers. If you see, toss a coins mean if I am tossing a coin, okay, and I'm rolling a dice or die, whatever you say. So when we're tossing a coin, I can have tail. Rolling the dice, I can have 1. So one outcome is tail and 1. Second times the coin gives me tail and the dice give me 2. The second outcome is tail and 2. Third times I tossed the coin, let us assume it gave me tail again, but I rolled the dice, it gave me 3. So third outcome is tail 3, tail 4, tail 5, tail 6. And then heads is waiting for why you are counting all the time tails. So the coin can have tail, heads on, heads 1, heads 2, heads 3, heads 4, and so on. It means 1, 2, 3, 4, 5, 6, 6 2s are 12. Here we can say the total number of possible outcomes is 12 here. Okay, in that way we can frame our sample space, because without sample space you are nothing in probability. Okay, so the question is a probability of a tails with odd number. So we have to count those outcomes which have tail and odd number. So tail and odd number, and moreover tail and odd number. Fair enough. We are having 3 only. So 3 over 12 we are having probability of 1 by 4. Okay, fair enough. And probability of heads and prime number. Okay, so we have to understand very carefully that what are the prime numbers. Prime numbers are the numbers which have only 2 factors. Prime numbers are the numbers which have only 2 factors. 2 factor means the number and factors are 2. The number itself and 1. 1 is a factor of every number, we do not worry about 1, but the other factor is the number itself. For example, 2, if we break 3, you are going to get 1 and 3. Break 5, you are going to get 1 and 5 only. No other factor will be appearing here. And you need to remember that 1 is neither prime nor composite, and 1 will not be considered in any way. So we are looking for heads and prime. So this is heads and prime, heads and prime, heads and prime. So we are having 3 outcomes again. So 3 by 12, and the answer is going to be 1 by 4. That is the way how we deal with this kind of problems. Now, next question is when we are having a roll of 2 dice. So we are having 2 dice and we roll them simultaneously. What we can have? On the first die I can have 1. On the second die, I can have 1, I can have 2, I can have 3, 4, 5, 6. It means the list comes out to be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. On the second die, second roll, for an example, I am having 2 on the first die. The second die can have 1, 2, 3, 4, 5, 6. It's meant 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. The first die I am rolling, it is having 3, and the second die can have any number. So this is the way how we try to make the list of all possible outcomes. So we are taking 1, 2, 3, 4, 5, 6, and that is very easy way to construct this kind of table. What you need to do, try to see the white numbers, the numbers which I have written in white. Write 1 to 6, 1 to 6, 1 to 6, so on vertically for 6 times. Ignore the pink numbers. Write the vertical numbers 1 to 6 counting 6 times. Then write the 1 to 6 horizontal counting 6 times. Just ahead these white numbers. 1, 2, 3, 4, 5, 6, and so on. And horizontal 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and so on. And you will be having the table. You do not need to remember anything. So there are total 36 possible outcomes when 2 dice are thrown simultaneously. And if you throw 2 dice, your answer is going to be any of these outcomes. And these kind of questions can be asked. Probability of doublet or same number. Same number means 1, 1, 2, 2, 3, 3, 4, 4. Doublet means the same. So how do we get those numbers? So if there is a 1 to 2 ways. One, you find the numbers one by juggling in the whole of the table, or you can find some certain pattern from the table. So let us see if you are looking for doublet of numbers. So what I am going to make here, if you see carefully here, ignore if I am entering in some other line also. Okay, no, this is not working. Okay, let me try again. See this diagonal. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So hence these are 6 outcomes, and the probability of getting the doublet is 6 by 36 and 1 by 6. That is how observation works. The next question, sum of the numbers is 8. Sum on the numbers is 8. So we have to find out which terms are having sum as 8. It is not for about 8 only. You can be asked some 7, some 8, some prime number, some odd number, like some composite number, anything you can be asked. And I'll show you some pattern here if you look it carefully. Okay, let me draw here. If you see this first diagonal, the sum is 2. If you see this second diagonal, if I make it a little like this, okay. Here is sum is 3. If you see the third diagonal, the sum is 4. Fourth diagonal, the sum is 5. Fifth diagonal, the sum is 6. Sixth diagonal, which is the longest one. This is the longest one, corner to corner. That is having sum 7. All the numbers 7, 7, 7, 7, 7. Next, sum 8, sum 9, sum 10, sum 11, and sum 12. So that is a simple way. You do not need to count it, find out. Not all the way, but most of the time it can work for you. So what we are looking for, sum is 8. So 8 is here. 8 is here. So how many terms are there? 1, 2, 3, 4, 5. So we have the probability of 5 over 36. Product is 10. Okay. The next question is find the probability of when the product is 10 on both the numbers, on both the dice. So there are 2 ways. You can go to the table and find the numbers which can have product 10. But I think you do not need to go to the table. You need to factor 10. So product 10, it means what are the factors? So we are having 1 into 10 and 2 into 5. Those are the only 2 pair of numbers which make 10 by multiplying. So 1 and 10 cannot be considered because dice doesn't have 10. So this is gone. Okay, this pair is gone. So what we are left with here? We are left with only 2 and 5. So 2 and 5. How many outcomes are there without looking at the table which can have 2 and 5? There are only 2 outcomes. 5 and 2, 2 and 5. So hence probability is going to be, probability of product 10 is going to be 2 out of 36 is equal to, and if you simplify the answer, you'll get the answer. Okay, now next thing is probability of finding the composite on the first number and prime number on the second. When you have been written first and second, it means the order is very, very important. Order of writing is very, very important. So first composite, if you see carefully, you have to look at the table and find it out where you have the composite number on the first. So first number are these white numbers. So composite number is like composite number. You should be aware about composite numbers. So composite numbers are which are not prime or which have more than 2 factors including 1. For example, 4. So 4's factor can be 1, 2 and 4. So hence 4 would be considered as a composite number. So what composite number we can have here? We are having here 4 and 6. These 2 composite numbers. Hence this whole of the rows would be having the first digit as composite number. And what is the second condition? Second was prime number on the second. And let us see prime numbers. Here prime, here is prime and here is prime. So it means if you intersect these two, you will be having this arrow and this arrow. You will be having 4, 2, 4, 3 and 4, 5. You have to intersect the arrows. This arrow and this arrow, they meet at here. This arrow and this arrow, they meet at here and they meet at here. So hence there are total 6 cases which can give you on first dice would be having composite and the second dice would be having prime number. Hence the probability is going to be 1 by 6. In that way there are many scopes which can be discussed, but I do not want this video to be extended on a very long length. We'll be discussing those problems in the further past paper problems. Okay, now the important thing, tree diagrams. Tree diagrams are very, very useful. Before discussing the tree diagrams, you need to have a basic idea of the things that, just a moment, basic idea of the things. The first thing is mutually exclusive. Mutually exclusive means 2 events which are when they cannot occur on the same time. Mutually exclusive means they cannot occur on the same time. In that case, what kind of English word we use to consider for ourselves? The word is or is generally used. I'll give you an example. And when we have or word in probability, it means we have to use the plus sign. For an example, if you are having 4 balls, let us assume here 3 red balls and 2 blue balls. If you are mixed the balls, you have mixed the balls and you are taking 1 ball out of the box, then what you can have here? You can have either red or blue. See carefully. You are allowed to take 1 ball, and when you are taking 1 ball, it can be 1 ball. So it can be either red or blue. So both the cases cannot happen simultaneously. Both of the balls cannot be taken out simultaneously. Either this or this. That case, the events are called mutually exclusive. and we use or word, and when we use the or word we have plus sign. It means if we are taking a ball, then it can be either red or blue. So we'll add the probability of red and blue simultaneously. We add them. Okay. The second thing is when we have something different like these are called like dependent events. Dependent even it means both the events can occur simultaneously. Both the events can occur simultaneously. For example, there is a favorite questions of the kids. On a rainy day, there would be a rain. We are going to discuss this problem in the next case. Nate, rain or not rain. If there is rain, the student is going to go to the school by walk or by bus. And if there is no rain, the student going to school by walk and by school bus. So here, what is happening? Two cases are happening simultaneously. The student, if there is, let us assume there is rainy day. The student is going to school if there is a rainy day and student is going to the school by walk. What is the probability that on the rainy day student is going to school by walk? Rainy day is happening and the walking is also happening. Rainy day happening and after that the walking is also happening. When both the cases are happening simultaneously, then what we do? Probability of first event into probability of second event. That is a theoretical way of dealing the problem. So in the further problems we will be discussing the problems which will give you an insight how to deal with. Okay, so mutually exclusive and dependent events. Let us see how this works. Tree diagram. What we are having here, for an example, we are having 4 blue balls, 6 yellow balls, and total we are having 10 balls here. And in the tree diagram questions, generally, not in the tree diagrams, there are two possibilities when we are choosing something. So there is, the first possibility is with replacement and the second possibility is without replacement. With replacement means, for an example, a jar is having 10 balls. I took a ball, it was white, and I noted the color on the paper and I put it back. I replaced the ball again with it within the box. The second time I put the ball, I took a red ball, I noted the color, then I put it again back. The number of balls, total number of balls will interact as it was in the beginning. So that is called with replacement. With replacement, we are putting the ball again and the total number of balls are not being affected. So how the tree diagram works? Condition, you need to remember that we are talking about with replacement. Okay, what is happening? We are having 4 balls, 6 yellow, 10 balls, 4 blue and 6 yellow. So for an example, what are the possibilities I can have? I can have a blue ball or I can have a yellow ball. Okay. So let us see the probability tree, how it works. Oh, see carefully, 4 balls, and what is the probability of blue ball? Because we are having total 10 balls and blue are 4, it means the probability is going to be 4 out of 10. And on the tree diagram itself, you do not need to like simplify your answers. Whatever the fraction you are getting, you need to write that fraction. Okay. If you want to write the simplified fraction, that is not a problem. But if you write this will work for you. And on the yellow, we are having 6 yellow balls, and the probability is going to be 6 by 10. Because I noted the blue color and I put the ball back, hence the number of balls are same again. So when I got a blue ball, then I again found a ball from the bag again, and there is that ball, second ball can be blue and can be yellow. I am not sure. So because it is a with replacement case, so number of balls had not been changed. I took a ball and I put it again, so hence we are having again 4 balls here and 4 blue balls and 6 yellow balls. Total balls are 10 again. And getting a probability of blue is 4 and total is 10 again. Number of balls had not been affected. And probability of yellow again 6 yellow and total 10. In the same case, if I got a yellow ball, then I drew another ball again, then what we are getting here, because number of balls are not affected at all, so we are having 4 blue balls and 6 yellow. It means number of balls are same, so 4 over 10 and 6 over 10. So that is the case how you fill the tree diagram. You need to find the condition, it is with replacement or without replacement. So today in this problem we are talking about with replacement. Okay, so which kind of questions can be asked? For an example, before discussing the questions, let us have one basic idea which we have already discussed. This is the shortcut which we can use. See carefully. I have gave you an idea what are mutually exclusive and what are dependent events. In that sense, sum of all branches from the same point is 1. Sum of all branches means probabilities, sum of probabilities of all the branches at the same branch. This is the point and we are having 2 branches here. If you add them, these 2 will have probability always 1. This is the point and these are the 2 branches. And the sum of the probabilities of these 2 branches is 1. There may be 3 branches. So sum of all 3 branches would be same from 1 point. This is the point and sum of the probabilities of these 2 branches is going to be 1. You need to remember that. And the second thing is when we multiply the probabilities in the same straight line like this. If we have to calculate the probability of blue and blue, we are moving in a line, kind of a line, okay? So then we have to multiply the probabilities. So that is a simple way to memorize the things if you want to memorize. But if you do with the concept, then the things would be good for you. For an example, what we are looking at, probability of blue and blue, probability of getting blue. So first we will enter here, blue, the probability is 4 by 10 and then again blue, the probability is 4 by 10. It means first I got blue, then simultaneously I got blue again. It means both the events are happening simultaneously, so hence these will be multiplied and the probability is going to be 4 by 10 times 4 by 10 and the answer is going to be 4 by 25 after simplifying. I hope it makes sense. And for an example, you are looking for a probability of yellow and yellow. So this is the yellow thing and the probability is 6 by 10 and this is the yellow thing again, the probability is 6 by 10 again. So hence, because both of the things are happening simultaneously and they are in the same straight line, let us assume, not exactly line but try to understand the context behind. So probability is 6 by 10 times 6 by 10, I got 0.36. In that way we can find the answers. And here you can be asked one more problem. Let us assume probability of blue then yellow. The first ball is blue and the second ball is yellow. What is the probability? So first of all, first ball is blue, then we are almost here. Try to understand carefully. Okay, here. First ball is blue, the probability is 4 by 10. Second ball is yellow and the probability is 6 by 10. Then we have to multiply blue times yellow, probability of blue 4 by 10 and yellow 6 by 10. It means the answer we are going to have 4 by 10 times yellow, that is 6 by 10. The answer comes out to be 24 over 100 or it can be written as 0.24, or you can write according to the problem you can write the answer in simplified fractions. So that is how things with replacement, how the tree diagram works. You have to start with problems. In the next video, I'll be bringing a lot of problems in which we'll be discussing all the concepts from the practical state. Second is without replacement. How these thing works. Okay, let us see. Okay, so how the practical problem will work on the tree diagram without replacement. And let us assume what we are having here in the beginning. We are having a bag which is containing some balls. Let us assume we are having 8 blue balls, and let us assume 6 red balls, and the total is 14. Okay, so now how the tree diagram will work, see carefully. What is happening in the beginning, you need to make the jar or this diagram on every point on the tree diagram, because the number are going to be changed. So in the first thing, what we have here, 8 blue and 6 red, it means total is 14. Okay, so we took a blue ball, and what is the probability for blue? The probability is blue is 8 blue balls upon total balls are 14, so hence probability of blue is 14, 8 over 14. Now probability for not pink, I took red here, so let us write red. Okay, now probability of red. So how many red balls are there? 6 red ball, total balls are 16, so it would be 6 over 14. Because this case is without replacement, in that sense what we think that we had a blue ball, we opted a blue ball and we throw it out. Now the number of blue balls are reduced and the total number of balls obviously will reduce. So here, to avoid the confusion, what we are going to do here, we are going to make our bag again what we are left with. So we dropped one blue ball, we were having 8 blue balls, now we are left with 7 blue balls. 7 blue balls, and because red balls have not been taken in this case, in the first blue case, so we are having 6 red balls and total is 13. Okay, and here we have to make the jar here also. If we choose red ball, it means blue balls are same, we hadn't touched blue ball. Okay, those are the different things. So we take red, then out of 8 balls, blue balls, we are having 8 blue, and out of 6 red, we dropped 1 red, therefore we are left with 5 red. This means total we are having 13. So whenever, if the tree diagram is expanding further, then you need to draw these jars or these bags every time, some certain rough figure which can give you clear numbers. Okay, so the probability of blue is 8 by 14, probability of red is 6 by 14. Now if we are having blue and blue, let us move further. Now we are having 7 blue balls here and total balls are 13. So hence the probability of getting the blue again is 7 by 13. And it means the probability of getting blue and blue is 8 by 14 times 7 by 13. One ball is reduced. And here if we are going to take the red ball, red. So what we are having here, 6 red balls and total is 13. And you need to remember this, the sum of branches at the point have probability sum as 1. If you are making some mistake, you can verify your answer. 7 plus 6, 13 by 13, that is 1. Okay, and if we are looking here, then for the red, the probability is 6 by 14. And then the next case, 8 balls are impacted as it is, but total number of ball is reduced because we threw red ball. 8 by 13, and for we are having a red ball here, So how many red balls we are left with? 5, and total balls are 13. See, the sum is again 1. So when we add the branches from the point, the sum of the probability is always 1. Okay, we are having this to complete the T-gram. We have done it. Now let us solve some problems. So if you are asked probability of getting blue and red, it means the question can be asked that in the first trial the person get the blue ball, in the second trial he got the, let us assume, red ball. So what are the probabilities? The probability of getting blue and red. So probability of getting blue is 8 by 14, and see carefully, the word here is and. Okay, so that will give you an idea that we have to multiply. So 8 by 14, and probability of red is 6 by 13, and we'll multiply these two and we'll get the answer. Okay, and let us assume we are solving probability of blue and blue. So probability of blue is 8 by 14, and probability of like blue again is 7 by 13, and we'll multiply. So in that way we can find all of the probabilities and we can complete the T diagram. To complete the diagram, you need to remember that sum of these two is 1, sum of these two is 1, sum of these two is 1. Okay, so there is 8 by 13, so out of 13 we are left with 5 only, so hence it has to be 5 by 13. In that way we can solve these T diagrams, and you need to remember that if we are having AND situation, then we need to multiply. If we are having OR situation, you have to add. Then these are the things which can be learnt by the practice, not theory. Will not, you will not remember the things. So hence we are having a lot of questions which we are going to solve, and let us see the past paper problems, how they behave in the exams. Okay.